So, good day everyone. You're welcome to my YouTube channel, and this is IX. Today we'll be looking at how to evaluate these two limit questions. Yes, and they are beautiful ones as you can see them. So, for question number one, the limit of x approaching infinity for x plus 5 all over x plus 6 all raised to the power of x. Of course, substitution will not work there because we'll end up with something like 1 raised to the power of infinity, which is actually indeterminate. And so we'll look at how to evaluate it using application of logarithm. So for this, let y be equal to, let y be equal to x plus 5 all over x plus 6 all raised to the power of x by the introduction of ln, which is logarithm. The introduction of logarithm, we'll get the ln of y equal to x ln of x plus 5 all over x plus 6. Better way of writing. Yes. Now, what we have here, we want to use our L'Hopital rule, but then L'Hopital rule will actually not work for products. It only works for quotients. So we are going to make something out of this, and by that we'll get ln of y equal to ln of x plus 5 all over x plus 6 divided by 1 all over x. Of course, this is same thing as x ln of x plus 5 all over x plus 6. Now we can differentiate both sides right now. So differentiating both sides, differentiating here and here rather, the numerator and the denominator, we are going to get for ln of x plus 5 all over x plus 6, to differentiate it, we'll get x plus 6 into 1 minus x plus 5 into 1 all over x plus 6 all squared. X plus 6 all squared divided by x plus 5 all over x plus 6, which will give us x minus x is 0, 6 minus 5 is 1. So we have 1 all over x plus 6 squared divided by x plus 5 all over x plus 6. Yes, we can take good care of that to get 1 all over x plus 6 squared times x plus 6 all over x plus 5 by inverting the division sign to multiplication. So we can quickly do that. This will become 1 all over x plus 6 times x plus 5. So this is the derivative of ln of x plus 5 over x plus 6. And if we differentiate 1 over x, we are going to get differentiation of 1 over x. We differentiate 1 over x, we will get negative 1 over x squared. So dividing this by negative 1 over x squared, yes, you see, dividing this by negative 1 over x squared, this is what we'll get, which is finally equal to negative 1 over x squared, which is finally equal to negative is anything wrong anywhere? No. So which is equal to negative of x squared all over x plus 5 into x plus 6. Yeah, that's what we'll get. This will be equal to negative of x squared all over x plus 5 into x plus 6. And then remember, our equation has not changed. ln of y is equal to that, negative x squared all over x plus 5 into x plus 6. And remember, our limit approaches infinity. So if we take limit approaching infinity here, the highest power of the denominator is 2 and the highest power of the numerator is 2. Once the limit of our function is approaching infinity, the highest powers are equal, then your limit, your answer will be the coefficient of the highest powers, which is -1 and 1. So -1 over 1 will give us -1. So it means we'll get this to be ln of y equal to -1. And if we take the definition of logarithm, we will get y equal to e raised to the power of -1, which is equal to 1 all over e. So the evaluation of this limit is equal to 1 over e. Yes, so we can really take a good look at it. Yes, I'm giving you some time to take a good look at it, and then so we can move on to the next question. Okay, I'm sure I can clean from this part now. From this part now. So we'll do question number 2. For question number 2, as the limit approaches infinity, x into ln of x minus ln of x plus 2. Okay, so what do you think we should do? Yeah, we can actually simplify. You can actually simplify. This is logarithm and this is logarithm, and what we have here in the middle, the operation there is subtraction. So we can take the rule of logarithm. This will definitely give us limit as x approaches infinity, x ln x all over x plus 2. Yeah, I'm sure you never saw that coming. So at this point, we're having a product rule. What we need to do is we're having a product. So what we need to do is to make a quotient out of it, because L'Hopital rule will never work for products, right? So we want to make a quotient out of it. And to do that, we get limit as x approaches infinity, ln of x all over x plus 2 divided by 1 all over x. Sure. So we can move on there to do our differentiations. So coming over to this point to do the differentiations. Okay, so we can take the differentiation of ln of x all over x plus 2, just like we did for the previous one. Remember, to take your differentiation of logarithm, all you have is u prime all over u. That means derivative of the function divided by the function itself. So for x all over x plus 2, we are getting x, okay, we'll get x plus 2 into 1 minus x into 1 all over x plus 2 squared, which will give us x plus 2 minus x, which is 2 all over x plus 2 squared. So that's the derivative of x all over x plus 2. But then we have to differentiate that. We have to divide that by 2. We get that to be 2. So this will be 2 all over x plus 2 squared divided by the original function itself, which is x all over x plus 2, right? We can make that to become 2 all over x plus 2 squared times x plus 2 all over x. This can cancel out this, leaving you with one of these. So you finally will have 2 all over x plus 2 times x. So that's the derivative for ln of x all over x plus 2. Now how about the derivative of 1 over x? Just like we did the previous time, when we differentiate 1 over x, we'll get, yeah, you're right, negative 1 over x squared. You're right, yeah. So we are dividing this now by negative 1 over x squared. If we divide 2 all over x x plus 2 by negative 1 over x squared, dividing it by negative 1 over x squared, negative 1 over x squared. How about we do it this way? Divided by negative 1 over x squared. And then we decide to say this is 2 all over x into x plus 2 times minus x squared. Yes. So finally, we'll get negative 2x squared all over x plus 2. Yeah. And if we take our limits, just like our question said, if we take our limits as limits of x approaches infinity, we'll see that the powers of the highest power of the numerator and the power of the denominator is equal, and therefore our answer will actually just be their coefficient. And what will be the coefficient of the numerator? Minus 2. And the coefficient of the denominator is minus 1, is actually 1 rather. So minus 2 all over 1, minus 2 over 1 is equal to minus 2. And therefore, the evaluation of the limit is equal to minus 2. Okay, so this is a very beautiful limit, and subsequently, I'll bring to your doorstep much more beautiful limits. Up until I come your way, thank you so much. I'm sure you like, subscribe, and if you find this video helpful, share with your friends. Thank you.